Hey, Jody here with WeldingTipsAndTricks.com. Today we're doing a little short circuit MIG welding with C25 gas, some stick welding with 7018 1/8, and some dual shield flux core. All on one machine, the little 210 MP. As we go, we'll talk a little bit about what this machine can't do, what it can do, some of the drawbacks, some of the pros and cons. Let's get into it. This is a multi-process machine. That's what the MP stands for. So it will do MIG welding, it'll do lift Art TIG on DC only, and it'll do stick welding. I'm going to do MIG welding to start with using 030 diameter wire, 19 volts, 330 inches a minute. That's the default setting for 3/16 of an inch thick metal. This is 1/4 inch metal that I'm welding here, so it does look just a little bit cold. We'll do a little bit of testing on this a little bit later. Watch this now, though. I also dropped the wire feed speed just a little bit, and look at the difference in spatter. One of them's got a much more efficient burn. Both of them are going in okay, but you're just going to get more spatter when you don't have the sweet spot setting dialed in. We'll go the other direction here now, 330 inches a minute here. I did a little pushing, I did a little pulling. It's hard to tell what I'm doing with the camera angles here. Sometimes the camera is deceptive on how much gun angle there is, but this looks like a slight pull here. And again, when I'm finished with the joint, it went along rather slowly, and it looks a little bit cold, so let's test it. I want to see how cold it was, just whether or not it got in there or not. And you can see right down in there in the very bottom of the joint, there's just a little dot, like some kind of little minute lack of fusion. It did okay, actually, for what it looked like. There's a little suspect area right there. It's kind of a straight line, but I don't think it's lack of fusion. Just a tiny little lack of fusion in the very bottom of the root of the joint. Let's swap over to 035 wire now. Now I've got some higher default settings for what thickness I'm welding. And the default settings for this 035 wire were kind of high. I mean, it was actually stubbing, and that's kind of how you can tell when you've got too much wire feed speed. You'll get a little sputter sometimes. It'll stutter, and sometimes that can be the ground. You want to make sure you have a really good ground here too, or it can fool you and you can chase your tail. But I did drop the wire feed speed to 290 here, and things smoothed out quite a bit. So I decided to test that one as well, and you can see it punched down in there to the root quite a bit better. There's still that little area though up top on that top leg that's kind of a straight line. I didn't really love that. Let's swap over to stick rod now. 7018 1/8 rod. And we're going to try 125 amps. A good rule of thumb for 7018 is 1 amp per 1/1000th of thickness. So it's 1/8 of an inch. That's 125 thousandths. A good starting point is 125 amps. I'm trying to take this thing all the way up to the edge, a full 1/4 inch fillet, and still not get undercut. And it's kind of difficult to not chew that corner off just a little bit. So in those cases, sometimes it would be better just to run 2 passes, run a really quick small one like this, and then let it cool a little bit, chip the slag, and then come back over it with a second pass. That's usually a little bit easier to fill in that way, although I didn't do such a great job here. I didn't hold the top long enough, or I had too long of an arc, or I was shaking too much or something. But you'll see when I chip this slag off, I've got just a little bit of undercut on the corner there. I got to work on some practice. I happen to run one here and just time it and see how long it would take to make this weld. Just long enough to flick the slag off and then change rods and then get back in there. And it was pretty much 2 minutes, like 1.9 minutes, I think. Almost twice as long as it would take to do what I've done so far with the short circuit MIG. So you can see why MIG a lot of times is just more productive. Stick is the way to go outdoors. When you really need to know that weld is in there and you're fighting some wind and all that, stick is a good choice. It's not nearly as productive as, say, dual shield flux core, and that's what we're going to do next. Dual shield flux core with that flux in there really helps welding over some hot rolled mill scale, the kind of mill scale that comes on square tubing and box tubing and structural shapes like that. If you can't get it all cleaned off, the dual shield flux core doesn't seem to mind it too much. This is cold rolled I'm welding on here now. It's just got a little oxidation. So it should do just fine as far as penetration and all that goes. I've got kind of a low setting here. I would use this setting on out of position stuff. But that took 53 seconds and just a few seconds to clean up. It's a lot easier to clean up usually than stick welding if you have the settings down pretty good. I was able to visit my friend JD a couple weeks ago, and he was building a 60-foot long rack. That was one of the videos we posted a couple weeks ago, and these were the settings that he used with 035 dual shield flux core on all that stuff. And it did just fine, went in just fine on the horizontal joints like this, as well as the vertical uphill. So I thought I would test those settings, those same settings, using the same wire that JD used at home on my 210 MP. That was a 256, Power MIG 256, not a multi-process welder, strictly a MIG welder. That's what JD used right here. Using these settings at home worked okay on the flat stuff. Really did punch in there pretty well. And the little 210 could actually handle that high wire feed speed for at least these 8-inch runs, no problem. The only problem with when you start getting up in the high end of the settings on a particular diameter wire, you can get these little worm tracks like this. So you can, it could be your stick out, it could be a little bit too high on the voltage, or you're just a little too hot. But usually it's a surface condition, grinds right out. So I dropped the settings down here a little bit, 22 volts and 333 inches a minute, and decided to just run a vertical uphill. And so that's what I'm doing right here. You can see I'm using very slight torch manipulation. I'm just trying to keep that nozzle pointed dead nuts straight in, 90 degrees, no push, no pull, no nothing. And here it looks like I'm doing quite a push, but I don't think I was anyway. It's hard to tell when you're under the helmet sometimes. But that one will cut and etch as well. That one turned out halfway decent. Slag came right off. Don't see any worm tracks in that one, so lowering those values a little bit seemed to help there. So we'll do a little quick cut and etch on that, and man, that's just about picture perfect weld nugget right there. No suspect areas. It punched down into the root. It's all nice and uniform. Now part of that is because it's dual shield, and I'm sure part of it is because I ran it vertical uphill. Should have probably kept them all the same. Well, that was pretty interesting. I learned something every time I do a video like this. I got to looking back on my YouTube history of videos that I've posted, and I counted up somewhere around 18 videos that I've done using this machine so far. So I've done stuff with Art TIG on socket welds. I worked with JD on that awning where he was using a spool gun run off a generator. Lots of stuff. So I'm going to show a few clips of that stuff now, and we'll talk about the ins and outs as we go. Let's get into that. This machine will do Art TIG in addition to MIG and flux core and stick. And here I'm walking the cup using a torch with a valve on it that I just clamped a stinger to an adapter block, and I'm not using a foot pedal or anything. The machine does have the capability of hooking up a foot pedal, but I'm not using one here. It's a very common way to do socket welds. So this machine will do DC Art TIG. You won't be able to TIG aluminum with it. And when you get finished, you want to terminate a bead, you just got to snap out like that. It's very common in the pipe fitting industry to use scratch start and Art TIG units for work like this. Kind of better actually than trying to have to keep your foot on a foot pedal while you're shuffling around a pipe vise or something. Here I'm not walking the cup. I'm just using a TIG finger, bearing down on the tip of that wire. They call this a lay wire technique. You're not dipping the wire in and out. You're just walking over the top of the wire. Here's another way of propping. You can see that otherwise my finger would be, I'd have to figure out a different way to prop because your finger would just really get too hot like this, but it helps to steady up. And here I'll put the second pass on real quick, just showing it's very similar to walking the cup. You just kind of try to mimic that Z-weave type motion that you get out of walking the cup, and you're just freehanding instead, or in this case again propping with a TIG finger. JD built a fire pit using the plasma cam to cut out all the pieces and shapes and logos and everything. This is Zach's dog Tilly. She's a good girl. And those are the settings to start with using short arc MIG. Ran some beads here on these outside corner joints, just dragging the puddle along, hardly any manipulation at all. And that did a fine job. Nice bead there, nice smooth bead. Those are the settings that were used. And then to swap over to dual shield flux core, of course you have to use knurled rollers and a little bit different settings. It's pretty easy to swap over. And this is a little quick shot of that. A little bit of cleanup on dual shield. but it sure does burn in there, especially over hot rolled mill scale like it's on here. Not every machine will do a good job running off a generator, but this one will. I know it'll run an aluminum spool gun with no problem off this generator here, because JD was pushing it pretty good that day. This was an aluminum awning build. Outdoors doing welding on an aluminum awning, no hiccups. And that's a really nice feature to be able to run off a generator or a drop cord without constantly popping a breaker or something. I did a little quick push-pull test here a while back. 19 volts, 330 inches a minute. I tried to keep everything the same here. I'm just going to show you this. It was a fun little video to do. There's always that argument about push versus pulling. Some people like to push, some people like to pull. And I think as long as you stay toward the front of that puddle and you keep your stick out to a short enough length, you got your settings pretty much dialed in, you can most of the time be okay with pushing or pulling, which is a good thing, because sometimes you don't have a choice. Sometimes you've got your head up in some area, a structure, a piece of box tubing, or building a platform or whatever, and you just either got to weld to you or away from you, and you just can't get the gun angle you want. And so it's good that you can make it work both ways. Now the argument comes in a lot because there's different modes of MIG welding. This is short circuit MIG. If I was doing spray MIG, I'd largely be pushing. Alright, so I did a push, I did a pull, I cooled them off, I cut them, I sectioned them. You can see there's just minute differences in the two, and all these weld nuggets, they're all okay. Most small machines like this in this price range will not weld with a 6010 rod. Unless they say they do, they probably don't. This one doesn't, but it does fine with the 6011. So I did this little portable job here on a friend's garage door, some brackets on there, running a 6011 off a drop cord. Did great. So in other words, if you're getting a machine thinking you're going to practice a 6010 route for a welding test, this is not the one for you. Now here's something. If you can burn a 1/8 rod continuously without overheating the machine, you're really not limited on the thickness of metal you can weld. Like if you were doing multi-passes like this on a big wedge on a log splitter or something, as long as you can burn a 1/8 rod and burn it at about 140 amps, you can put in a multi-pass weld on just about as thick metal as you want to. Won't be the fastest way to do it, but it'll do it, and it'll do a good job. Wrap this video up by recommending a couple of books. I've recommended this one many times before, Metals and How to Weld Them. You can get it at the James F. Lincoln Foundation at jflf.org. That's the nonprofit arm of Lincoln Electric. That's the reason these books are so inexpensive, and they're really good books. This one also, the Procedure Handbook of Arc Welding, has got all kind of charts with parameters for MIG welding, dual shield flux core, etc. Now I will say this, it's probably only going to benefit those that live in the United States, because the shipping really goes up when you're talking about shipping internationally. But anybody in the USA, man, I highly recommend these.